Hello everyone, let's solve this problem. What are the plausible products for the SN2 reactions given below? So before we start, let's review the key characteristics of the SN2 reaction. So SN2 reactions are bimolecular, which means they involve both the nucleophile and the electrophile in the transition state for this step. SN2 involves the backside attack of the nucleophile and removal of the leaving group that occur simultaneously. And lastly, stereochemistry. So stereochemistry for SN2 reactions are always going to be reversed stereochemistry. Now we are ready to solve these two problems. So in I, we have 4-methyl benzene thiolate here and 1 bromopropane. And we need to determine which one is the nucleophile and which one is the electrophile. So let's look first at 4-methyl benzene thiolate. It has this sulfur atom with the negative charge. So this can act as a strong nucleophile. So let's label that as our nucleophile. And our 1-bromopropane has a good leaving group, the bromine atom. And it is withdrawing the electrons partially to this bromine atom, which means that this carbon bonded directly to the bromine atom is partially positively charged, which makes this a good carbon for the negatively charged nucleophilic sulfur ion to attack on, causing the leaving group to leave. When that happens, we're going to get propyl p-toluol sulfane product, where the sulfur here replaces the bromine atom. So we should have on the other side of the sulfur 1, 2, 3 carbon alkyl chain. So let's always make sure to double check our carbons and count them. So 1, 2, 3. Great. So I strongly recommend counting your carbons for SN2 problems, and you should be good to go each time. So that is our final answer for the first problem here. In the second problem, we are given prop 1-ine, 1-ite, and 1-bromohexane. Again, we need to identify the nucleophile and the electrophile. Starting with prop 1-ine, 1-ite, we can notice quite obviously that carbon is negatively charged here. So this makes it a strong nucleophile. Let's label that. And we know from the first problem that this bromine atom is going to be a good leaving group. So this will be the electrophile. And again, following the same process, we know this bromine atom is withdrawing the electrons, which leaves this carbon atom to be partially positively charged, giving this carbon nucleophile the ability to attack, replacing the bromine atom, and bromine will leave, giving us this known 2-ine product. Let's count our carbons as we did in the first problem to double check our work. So we have carbon replacing bromine, which means we should end up with an alkyl chain of 1, 2, 3, 4, 5, 6 carbons. Do we have 6 carbons bonded to the other side of this carbon nucleophile? 1, 2, 3, 4, 5, 6. Yes, we do. So the final answer would be these two products. Thank you very much for your time.